Hello everyone. We're in Unit 0 on day 12, day 13, talking about parallel and perpendicular lines. Alrighty, here we go. That first section says, what is a parallel line? Let's go ahead and write when two lines never touch. Or you could think about when two lines never cross. And let me give you a visual here. One line there kind of going on a diagonal, and I have a line riding kind of right next to it. If you imagine that this line went forever up and the other line went forever up, they're never going to touch, never going to intersect or cross at any point. Okay, so when you think about this one, let's think about that the slope for those two lines are the same. So what I mean by that is for my first line, my slope can be 4 over 5. So it would rise 4 over 5, rise 4 over 5. And that means my other line, if it's parallel, would be the exact same, rise 4 over 5, rise 4 over 5. Okay? A little bit different of a situation that we have going on is perpendicular lines. So what is a perpendicular line? Let's go ahead and write when two lines intersect. So this is when they actually do cross at some point. And again, let me give you an example here. So we have our diagonal, and let's say we have a diagonal going the other way, kind of through it. They're intersecting. They technically have to intersect at this 90-degree angle right here. But think about this. The slope is both opposite and the reciprocal. And let me show you with numbers here. So this first line that I drew in the beginning could have a slope of, 2. That means that this other line going through it must have a slope, if it's perpendicular, of -1/2. It's opposite with the signs, and then the numbers flip. It's the reciprocal. Okay, so there's the difference. We're going to practice identifying here. So it says, example, classify each of the following pairs of lines as either parallel, perpendicular, or neither. So we kind of have three choices. Let's look at the first example. All you have to do, if it's already written in slope-intercept form, is just check out the slope. So for this first equation, I have my slope of 1/2. For my second equation, I have my slope of -2. Okay, if it is perpendicular, they have to have opposite signs, which they do, and then they have to be reciprocals of each other. So this case, they both check out, so my lines are perpendicular lines. That means eventually when you graph these, those will cross. Let's look at problem 2. Now you just have everything in kind of table form. So I'm going to go ahead and label some x's and y. So x1, y1, x2, y2. This is going to help me find my slope. I'm going to find my slope for my first table, and then I'm going to find the slope for my second table. I'm going to go through this pretty quickly to find the slope, so if I'm going too fast, make sure you're pausing the video and slowing it down. So on top I'm going to have 12 minus 8. On the bottom, I'm going to have 2 minus 4. When I kind of reduce that down and clean it up, I'm going to have 4 over -2, reducing down to -2. And I'm going to circle that because I'm going to look at it in a second. On the other side, I'm going to label everything the exact same, find the slope the exact same way. And when I plug in, I'm going to have 5 minus 10. All over 3 minus 6. When I reduce that down, I have -5 over -3. The only thing I can do there is get rid of my negatives. Now, what I want to do is compare those two answers that I got. The first table, the first set of numbers, I got a slope of -2. The second table, I got a slope of 5 over 3. Are they opposites? Yes. One's negative, one's positive. However, are they reciprocals of each other? No. Okay, really those numbers kind of have nothing in common. So that means I'm going to have a situation where these are neither. Okay, last one, number 3 down below, gives you a visual representation. You can kind of see here that you have a little line and then a larger line kind of behind it. They're just laying on top of each other. So think about what this means, okay? If those lines are laying on top of each other, okay? Are these parallel, perpendicular, or neither? And this is where it gets a little bit tricky and you kind of have to think outside the box. In fact, these lines would be parallel. And the reason being is that they must have the same slope because they are basically the same line. Okay? Problem 4. Write an equation of a line in slope-intercept form that passes through the point 8, 2 and is perpendicular, key word, I'm going to highlight that, and is perpendicular to the slope of -2/3. Couple things to identify. It gives me a point. I'm going to label that point X and Y just to keep organized. And then it tells me slope. But I want to change the slope to be perpendicular. So I'm going to go ahead and write perpendicular and then M. So I'm going to change the slope. It was negative, so I'm going to now make it positive, and then I'm going to flip that number around. So the new slope that I want to use is this perpendicular slope. And then I'm going to use my X and my Y. Okay, I'm going to kind of write down a few other things. I'm going to write down my slope-intercept form. That's y equals mx plus b. At this time, I only know x, I only know y, and I only know m. I know nothing about b. So let's take a second, plug in the values we know, and find b. So I have 2 for y, 3/2 for m, 8 for x, and then I'm going to solve for b. When I do this, I'm going to have 2 is equal to, and when I multiply this fraction here, I'm going to get, let's see, 12, and then plus b. Then I have to subtract that 12 over, and I'm going to have -10 equals b. Again, I'm going to temporarily circle that because I'm going to use this in my final answer. So I want my final answer to be in slope-intercept form. That's y equals mx plus b. So I'm going to have y is equal to, and then 3/2 because that's my perpendicular slope, times x minus 10 because we just figured out that's what b equals to. Just remember the reason why I'm using 3/2 here is because we're looking for a perpendicular slope. So if you just need to make note of that. And we solved for that -10. Okay, last one. Problem 5. Write the equation of a line in slope-intercept form that passes through the point 16, -1 and is parallel. Okay, so key word there, parallel, to the slope 7/8. And if it helps you to think about that word parallel as kind of the same slope, then go ahead and think about it like that. So in this case, if I'm thinking about parallel slope, I don't change anything. I keep it the exact same. So this is my parallel slope I'm going to use. The other information it gave me was a coordinate, so x and y. I'm going to go ahead and write down slope-intercept form so I know where to plug in. I know y is -1. I know my parallel slope is 7/8. I know x is 16. And then I'm going to look and solve for b. Now I'm going to go ahead and multiply this piece right here, 7/8 times 16. When I do that, I'm going to end up with 14. Then I have to subtract 14 over. I'm left with -15 is equal to b. Again, I'm going to use that in 1 second here. So I want it to be in slope-intercept form. I want y equals, instead of m, I put 7/8, that's my parallel slope, times x minus 15, because minus 15 is what we just solved for. Again, I have 7/8 in the spot for m because we're looking for a parallel slope. So it stays the same. Again, if I went too fast or you just need to listen to one of the steps again, please rewind and go find what you need.